All right, example 5 says find the vertical asymptotes of the function y equals 3x minus 5 over x squared minus 6x plus 5 and confirm the answer by graphing the function. So a vertical asymptote is created when the denominator of a rational function equals 0 and the numerator doesn't. All right? So if my directions are specifically to find vertical asymptotes, okay, my procedure is going to be number 1, set the denominator equal to 0 and solve. I'm going to start there. So if I type, or if I just write x squared minus 6x plus 5 equals 0. Now it is a quadratic function, which means that the quadratic formula works. Factoring could work if we can see how to factor it. I always go to factoring first. If I can figure it out, great. Otherwise, I go to the quadratic formula. X minus 1 times x minus 5 will be the factored form of that. And since that's the factored form, that means x equals 1 or x equals 5 would be the vertical asymptotes. Now, when they ask for vertical asymptotes, they're asking for equations. Don't give me x equals 1 comma 5, right? X equals 1, that's equation 1. X equals 5 is equation 2. All right, each one individually is an equation. Now, those are only vertical asymptote equations if the top also does not equal 0 with those. And that's just a simple test. Change x to 1, 3 minus 5 is negative 2, that's not 0. X is 5, 15 minus 5 is 10 is not 0, so both of these are vertical asymptotes. All right? If this top said x minus 5, then this would be thrown out because it wouldn't be a vertical asymptote anymore. All right? It would actually be a hole in the graph is what would happen in that situation. Again, we dealt with that in geotrig last year. They want us to confirm the answer by graphing. So if we graph this, we should see it at 1, the graph's going to either go straight up or straight down. At 5, the graph's either going to go straight up or straight down. Let's try it out. So 3x minus 5, again, paying attention to detail, let's type it in. 3x minus 5 in parentheses, divided by parentheses, x squared minus 6x plus 5, in parentheses. The window I'm going to set here, I just need to make sure 1 and 5 are on it, right? So for the window, I'm going to say x equals, let's go negative 1, maybe. My calculator's hung up.
So x min negative 1?
Yeah, negative 1 or 0, something left at 1. Okay. Calculator's not cooperating. Try closing it out and see if I can get it to work. Oh well. Let's go negative 1 to 7 maybe. I don't know. It doesn't matter. Negative 10 to 10. And we'll probably look about like this. Okay, and hopefully, I'm trying to think, if I go really big negative, to start off looking like this maybe. And then maybe do something like this.
Other way.
Oh, it goes the other way?
Yeah. The first one goes down.
First one goes down, okay. So the first one goes down.
But it's below the x-axis.
Below the x-axis?
Yeah. There you
There we go, all right. And then the next one probably starts here and maybe does something weird like this.
go. Yeah.
And the next one maybe starts here and goes like that.
Yep.
All right, good. All right. High-tech stuff there. Okay. I'm going to punch out those cooperating instruments. All right.
Still not working.
Yeah, the point is though, at 1 and at 5, you got this, it's going straight down, it's going straight up look, right? So again, we can confirm vertical asymptotes by graphing. We could have also confirmed them by getting really, really close to 1 or 5 from left and right. We would have seen that as we get closer and closer to 1 from the left, it's going to negative infinity. Getting closer and closer to 1 from the right, it's going to positive infinity. 5 from the left, negative infinity. 5 from the right, positive infinity. So there's numerical ways to determine it also. But again, if the denominator is 0 and the top isn't 0, then you get a situation where it's going to either go to positive or negative infinity, creating therefore a vertical asymptote.
Just draw the graph.
Yeah, if it says confirm it, just give me a sketch of the graph, something like that on your paper would be sufficient. Doesn't have to be beautiful. Not as beautiful as mine, at least.
Yours is pretty good.
It's pretty good work there.
I don't even know if I can top that.
No.